Alright, so here is assignment 6.6, logarithmic and exponential equations. Starting with problem number 1, simple log equation says you have log base 2 of x equals 4. You want to start out with this one, simply changing it to an exponential equation. Remember, think base, it's always log base argument equals exponent, or log base answer equals exponent. And then you change it, you put the base and the exponent together, and that equals the answer. So you'll have 2 raised to the 4th power equals x, and x is 16 after you simplify this exponent here. Now, for number 2, we're solving another equation. We'll change this to exponential. We'll have 4 raised to the 3rd power equals 3 times x. 4 to the 3rd power is 64. You divide 3 on both sides, you end up with 64 over 3 equals x. For number 3, this time you have logs on both sides of the equation. Remember, for the log of something equals log of something situation, when you have the same base, you can just drop the logs from there. So we'll have x plus 2 equals 4. So we subtract 2 from both sides, and we end up with x equals 2. Number 4, you have another, is going to end up with a log equal log situation, but first we need to get it there. We need to take our coefficients and apply the power rule. We'll make those coefficients become the exponents. So you'll have log base 3 of x to the 1/2 equals log base 3 of 5 to the 3rd power. Now you can set your arguments equal to each other. We'll drop the logs. So we'll have x to the 1/2 power equals 5 to the 3rd power. And now we can simplify this exponent over here. We'll have 5 to the 3rd power being equal to 125. Remember now, x to the 1/2 power equals the square root of x. So we can square both sides, and we'll end up with x equals 15,625. Number 5 says you have 2 log base 7 of x equals negative log base 7 of 49. Again, you want to apply the power rule first so that we can end up with that log equals log situation. So we'll take this 2, this coefficient of 2, and make that the exponent. We'll take this coefficient of negative 1 and make that the exponent on this side. Remember now, when you have something raised to a negative power, you can make that become 1 over that number. So we'll have x squared equals 1 over 49. We want to take the square roots of both sides, so we end up with x equals positive or negative 1 over 7. Remember now, negatives are going to be restricted from our original problem. You can't have a negative here as your argument. Remember, your argument has to be greater than 0. So we throw away the negative 1, 7. Our final answer is x equals positive 1 over 7. For number 6 now, we have 2 log base 2 of x minus 8 equals log base 2 of 2. Plus log base 2 of 2 equals 3. So first we want to use the power rule over here on the left side. We'll take this 2, make that the exponent. Over here we have the same base argument situation. We'll change that, evaluate that, and change that to a 1. Now we need to subtract the 1 to this side of the equation. So that's how we get a 2 here. So now we have log base 2 of x squared minus 16x plus 64. And this expression came from this expression here. We did x minus 8 times x minus 8, and we went ahead and used the distributive property to FOIL it out. So now we have log base of something equals a number. So now we can change it to exponential form. So we'll put the base over here with our exponent on this side. So we'll have 2 squared equals x squared minus 16x plus 64. We'll simplify this exponent. 2 squared is 4. Now we have a quadratic here. So we want to set it equal to 0 because we'll need to factor it in this step. So we subtract 4 from both sides. So we end up with 0 equals x squared minus 16x plus 60. So now we can factor this expression here. we'll have x minus 6 times x minus 10. And now we can use the zero product property. We'll have x minus 6 equals 0 or x minus 10 equals 0. We end up with x equals 6 or x equals 10. Now we need to check the domain of our original equation to see which solutions are valid. Up here, we had x minus 8 as an argument. This has to be greater than 0. So x minus 8 greater than 0. We add 8 to both sides. We end up with x being required to be greater than 8. 6 is not greater than 8, so we throw that solution away. So we have x equals 10 and 10 only. Number 7, we're solving another logarithmic equation. We have log of x plus log of x minus 9 equals 1. So we're using common logs in this situation. We want to combine the logs over here on the left side using the product rule. We'll do x times x minus 9. We'll end up with log of x squared minus 9x equals 1. Remember, when you have the common log, that the base is 10. So we're going to do 10 raised to the first power when we change it to an exponential equation, and that will equal our argument, which is x squared minus 9x. So we'll be left with 10 equals x squared minus 9x. Again, we want to set it equal to 0 because we have a quadratic equation here. So we'll subtract 10 from both sides, and then we'll have 0 equals x squared minus 9x minus 10. We can factor this quadratic expression here. We'll have x minus 10 and x plus 1. Then we can use the zero product property. We'll have x minus 10 equals 0 or x plus 1 equals 0. The solutions that we end up with is x equals 10 or x equals negative 1. Going back to check our domain again, x has to be greater than 9, so x can be equal to 10 again. All right, so for number 8, we have another logarithmic equation. This time we start out with logs on different sides of the equation, but we want to move them to the same side so that we can combine them into one log expression using the properties of logarithms. So we'll start out by subtracting log of x minus 7 to both sides. So we'll have log of 5x plus 6 minus log of x minus 7 equals 1 now. So now on the left side, we can combine these two logs using the quotient rule. So we'll combine this and change this into division. So we'll have 5x plus 6 over x minus 7. So log of that equals 1. Now we can change it to an exponential. Remember, we have the common log here. When the basis is shown, it's understood to be a 10. So we have 10 to the first power equals 5x plus 6 over x minus 7. We can simplify 10 to the first power. That's simply just 10. Now we can multiply both sides by this denominator here because we want to take our variable out of the denominator. So we'll multiply everything by x minus 7 on the left and the right. We'll have to distribute this 10 times x minus 7. That gives us the 10x minus 70 over here on the left side. And then when we do this expression times x minus 7, these x minus 7 simply cancel out. So now we have 10x minus 70 equals 5x plus 6, and now we can just finish solving the equation from here. So now we'll have 5x minus 70 equals 6. We can add 70 to both sides and then divide by 5. Our final answer is going to be 76 over 5. For number 9, now we start out with the logs on the same side of the equation this time. So first we're going to combine using the product rule. So we need to now combine this addition and change that to multiplication between the arguments. So we can now distribute or FOIL this argument out. So we'll end up with x squared plus 42x plus 360 once we simplify everything. And then we can change it to an exponential equation. We'll put the base with the exponent. It'll be 3 to the 5th power now equals everything that we had for our argument. So we can simplify now. 3 to the 5th power is 243. We're going to need to take this quadratic equation and have it set equal to 0. So we'll have, after we subtract 243 from both sides, we'll end up with x squared plus 42x plus 117. Now we need to factor this equation. The factors of 117 that add to give us 42 is going to be 3 and 39. And once we have it factored, we can use the zero product property from there. And we'll be left with x plus 3 equals 0, or x plus 39 equals 0. We end up with x equals -3 or -39. Our domain requires that x be greater than -12, so x equals -3 is our only solution. Okay, so for number 10 now, we have logs on different sides of the equation to start out with. So we want to move the logs to be on the same side. So we'll add this log base 4 of x plus 56 to the left side. So now we see we have addition between logs with the same base. So we want to use the product rule to combine these two log expressions. So we'll combine it using multiplication between the arguments. So now we have another expression that we need to use the distributive property to FOIL out. So we'll end up with x squared plus 52x minus 224. And that will be equal to, the log of that will be equal to 4. So then we change it to exponential form. Now we have 4 raised to the 4th power equals x squared plus 52x minus 224. You simplify the exponent on the left. Once again, we want to have the quadratic equation to be solved for 0. So we'll subtract the 256 to the right side, and we'll end up with x squared plus 52x minus 480. We can factor that expression. We'll end up with x minus 8 times x plus 60. And we use the zero product property from there. We have x minus 8 equals 0, or x plus 60 equals 0. And then our final answers from that will be x equals 8 or -60. Going back to our original domain, from the left side, we have x is greater than 4. From the right side, we have x is greater than -56. However, the x being greater than 4 will trump that. So the final domain is going to be x is greater than 4. So the -60 will not be included. The final answer will just be x equals 8. For number 11 now, we have another log equation. This time we can go ahead and begin by using the logarithm rules. We'll use the quotient rule. In this case, the logs are already on the same side. So using the quotient rule now, we'll have the x squared plus x will be over the x squared minus x, which was subtracted. That goes to the denominator. Now we can change it to exponential form. We'll have 1 over 6, which is our base, raised to the -2 power, which is our exponent, equals our argument, x squared plus x over x squared minus x. Then from there, you want to simplify the exponent over here. You have a negative exponent. That means you can change it to its reciprocal. So 1 over 6 will change to just a regular 6. And now the exponent is positive. We have 6 squared, which is equal to 36. So now we have 36 equals that argument over there. Now we want to get the variables out of the denominator. So we will multiply both sides by that denominator, which is x squared minus x. We'll multiply it on the left and the right side of the equation. Then we can distribute the 36 on the left side. That will give us 36 x squared minus 36x. On the right side, remember now this denominator and the factor over here will just cancel one another. So we'll just be left with x squared plus x. Now we see we have a quadratic equation and we need to solve it. But first we're going to need to get everything on one side and have it set equal to 0. So we subtract x squared from 36x squared. That's how we get the 35x squared. We subtract x from -36x, and that is how we get the -37x. So now on the left side, we can factor out an x, not 35x. We factor out the x, and we end up with x times 35x minus 37x. From here, we can use the zero product property to get these two equations. We'll end up with x equals 0, or 37 over 35. From our original domains, x had to be less than -1 or greater than positive 1. If you set these both greater than 0, those are the intervals you come up with. So the final answer is 37/35.